So here we go. To even get it started, axioms, postulates, properties, and theorems. These are the things that we know, that we've seen and used, or started to see and use, and starting to understand. Subtraction property of equality, addition property of equality, division property of equality, substitution property, distributive property, definition of a midpoint. Now this one here, pretty much if we have a couple points, and we've seen this before as far as midpoint goes. I'll just sketch of my drawing. If we know B is the midpoint, then, so if B is a midpoint, then AB is congruent to BC. And that's just the definition of a midpoint. Also, definition of an angle bisector, same idea. If AC is a bisector, then angle 1 and angle 2 are congruent. We've also looked at symmetric property, transitive property, which seems to come up a lot, reflexive property as well, saying that if you're looking on a line segment here, whoa, terrible. If we're looking at a line segment, here, in this line segment, BC is congruent to BC. So it's part of both lines, but it is itself. And we kind of looked at it as if they were talking about the triangles. If we had two different triangles, a left triangle and a right triangle that were touching, here we would have BC. BC in the left triangle is congruent to BC in the right triangle. Similar reflexive property as far as angles are concerned. Ooh, kind of tough one to do. Here, if we look at the two different angles here, we can see that angle 2 is actually angle 2 in the red angle and angle 2 in the green angle. It's reflexive. So just a real quick once over of things that we've kind of mentioned already. Right angle congruence theorem, all it says is that all right angles are congruent. Kind of blatantly obvious. Linear pair postulate. If you have a line, what does that say? The linear pair postulate, it says that if you have two angles that form a line, two different angles that form a line, then the sum is equal to 180 degrees. And then the vertical angle theorem, which we'll kind of look at a little bit more today. Vertical angle theorem says this: if you have two lines that intersect, the vertical angles are congruent. So here, angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. And those are the properties that we've looked at so far. And so we're going to use those properties here to answer some of our questions. So, questions from the last assignment. How do you solve this one? This says S is equal to 2 times pi r squared plus 2 pi r h. And this just semicolon here means solve for h. I remember the question said something like solve for the given variable. Here, this is the given variable. To do this problem, what I would do is I would subtract 2 pi h on both sides of my equation using the subtraction property of equality. So I'm just trying to get h by itself. So I'm just going to get rid of everything over here. And that leaves me with s minus 2 pi r squared, which is now equal to 2 pi r h. So when doing this, we just pretend like we act as if all the other variables and numbers are just numbers. We can even group them together because we're just, they're multiplied. So here, this one would have been given. The second one here, subtraction property of equality. And the third one here, we're just going to divide this all out. We're just going to get rid of all of it. And this would all cancel out here and here, leaving me with s minus 2 pi r squared all over 2 pi r is equal to h. And that would have been division property of equality. So that's how you kind of step that one through. Still kind of getting used to this pencil. I'll move this over here a little. So that's what we're looking at here. Some people did go ahead and simplify that. This is where I stopped. You can simplify that, but we'll go from there. This was another one that seemed to give people trouble. In this here, all you're doing is solving for f. To do this, we started off with this was given to us. That was the very first thing that we knew. This was our given problem. From there, f minus 32 times 5 over 9. Here, what I would do is I'm going to get rid of this denominator first. So I'm going to multiply both sides of my equation by 9. And that's going to give me that's going to give me 9c is now equal to 5f. C is equal to f minus 32 times 5. From there, all of this is being multiplied, so I'm going to divide by 5 on both sides of my equation. I'm going to keep up with my multiplication. Division property. From there, that gives me 9 over 5c is equal to f minus 32. From there, I'm going to add 32 to both sides of my equation. So the fourth step here is going to be addition property of equality. And that gives me my final answer, not my final answer, 9/5 c plus 32 is equal to f. The last thing I'm going to do is I'm going to get that f equals piece here, so f is equal to 9/5 c plus 32, which is the symmetric property. And that is that problem there. The last problem that we had from our last assignment that tended to give people trouble was this one here. It could be a little tricky. Some of it is kind of reading what's happening first. So We had the idea of complete this table and show that the measurement of angle 2 here, I guess I'll do it in purple. This angle here is congruent to angle 3 here. This is the final thing I'm trying to get to. The best way to do this is to make sure that you understand what's written. The first thing here is angle 1 is congruent to angle 4. That's given. It also tells me that EHF is 90 degrees. We also say angle GHF is also 90 degrees. From there, I know that this is 90 and this is 90. So angle EHF is 90, angle GHF is 90. That means they're both equal to each other. Reason that we could use here is transitive property. From there, we have, they kind of write it a little bit backwards, but they say angle EHF plus is equal to angle 1 and angle 2. Likewise, angle GHF is angle 3 and angle 4. So we've seen that before. That's angle addition postulate. Angle addition postulate. Hey, there's no one here. It's just me. Angle addition postulate. Oh no. Don't hit the button. Angle. Here we go. Oh, he melted. And we will pause for a moment. Oh, he's fine. So, angle addition postulate. From there, once again, you can use that same idea. That's right, buddy. Those are going to turn. Those are wheels. Good job. From there, we also can use, we already know these are equal, so we are going to say these are equal, and now these two things are equal. Once again, transitive property. We're pausing.